the buck converter. The buck converter is a power converter which gets its output at voltage less than its input. The buck converter operates in two states. On state, the first one, and the second one is off state. It is on state when the current passes through the transistor, the inductor, the capacitor, and the load resistance. And when it is off state, it's when the current just passes through the inductor, the capacitor, and the load resistance. When capacitor and inductor charge and discharge? Well, we have the inductor charge from the current delivered by the VE source, and it's discharged when this same current passes through the inductor and the load resistance. For the capacitor, we know that it is charged from the voltage source Vin, and it's charged because it has in parallel the load resistance. Now we have mathematical calculations. On state, we have the Vin, the VL, that is the voltage of the inductor, and the Vout, that is the voltage or the capacitor of the load resistance, that is the same. So we have here the first equation, and we know that the voltage of an inductor is this one, this expression. So we replace in the first one and we get this. We solve the equation, and now we have this, that is the current of the inductor. For off state, we have the voltage of the inductor and the voltage of out, that is the voltage of the capacitor and the voltage of the voltage of the load resistance. So we have this equation, and we know the last expression that we saw, and the list we have the current of the inductor, that will be this expression. So now we have the graphics. Well, for these graphics, we are gonna analyze the first part, when it's on. It is on, we have the first expression that we have here, and with it off, we have this another equation that is represent like this graphic. Now we have the power buck converters. Well, they offer synchronous rectifications and have integrated a high and low level MOSFET transistor, eliminating the need for external diodes in the circuit. So they are designed to be used in wearables, devices, and applications for the internet, for things that require low power. For the next one, we have the USB on the go. Well, these things allows to connect keyboards, mice, and other peripherals to a smartphone. The peripheral device consumes power from the USB port of the phone. The power regulation is operated using a synchronous frequency converter that can transfer power in both directions. And for the last one, we have power amplifiers. So a big difference between DC-DC converter and a Class D audio amplifier is that while the DC-DC converter produces a fixed DC voltage over the line and the load, the Class D amplifier intentionally produces an AC signal. The difference is in the feedback cycle. Yeah, just that. Thank you.